Hey everyone, welcome to this explainer. Today we're decoding a fundamental piece of everyday tech that practically runs our modern lives, but man, does it constantly cause confusion. We're talking about the digital divide between the bit and the byte. If you've ever felt like your tech is playing some sort of trick on you, you are in exactly the right place. We're going to break this all down, structure it out, and clear out the confusion once and for all.
Okay, let's dive into this with a mystery that I guarantee almost everyone watching has experienced. Picture this. You just upgraded your internet package and the provider promised you a blazing fast 100 megabit per second connection. You go to download a 100 megabyte file expecting it to take exactly 1 second, but it doesn't. It takes 8 seconds. You sit there staring at the progress bar wondering, is my internet provider throttling me? Is my router broken? Or is this just classic marketing magic at play? Why is your speed seemingly falling so short of your expectations? Well, to solve this everyday frustration, we need to look at the absolute foundation of digital information.
Section 1. Defining the bit, smallest data unit. To solve our internet speed mystery, we really have to start as small as possible. The core concept here is the bit. As a quick foundational recap, a bit is literally the absolute smallest unit of digital data that exists in computing. Think of it kind of like a single light switch. It can only be in one of two states, on or off. In computer language, that translates to a 1 or a 0. Every single piece of digital info in the world, every email, every high-definition streaming movie, every video game you play, is ultimately just a massive, incredibly complex sequence of these tiny single bits. It is the fundamental building block of the entire digital universe.
Let's move to and see how this builds in Section 2. Defining the byte, grouping bits.
While bits are the essential building blocks, they're incredibly small. If computers only ever talked in individual bits, well, the numbers would be too astronomically huge for us to easily comprehend or organize. So computing engineers group them together. And that brings us to the byte. A byte is, quite simply, a unit of digital data that consists of a grouped collection of bits. If a bit is a single piece of paper, think of a byte as a folder containing a small stack of those papers. It's just a way to package the data so that your computer's processor can handle it way more efficiently.
Section 3. The Rule of 8. Connecting bit and byte.
Now, what's really interesting here is that this single number, 8, is the golden rule to solving our entire internet speed mystery. This isn't just some random variable. It is a hard, fast, structural law of computing. When data gets packaged up, 8 is the exact quantity that bridges the gap between the absolute smallest unit and the very next step up. Here is the formula laid out perfectly clear. 1 byte is exactly equal to 8 bits. That means whenever you're looking at a byte, you are looking at something mathematically 8 times larger than a bit. It takes 8 of those tiny light switch bits to create just one single byte of data. Keep this 8x multiplier in your head because it's absolutely crucial. It's the master key to understanding how your digital speeds and storage are actually being measured.
So the crucial point is how tech companies visually communicate this massive 8-byte difference to us. Because the words bit and byte sound so incredibly similar out loud, the industry uses a quick visual shorthand, capitalization. A lowercase b stands for bit. An uppercase b stands for byte. This tiny visual shift represents an 8-fold difference in data size. Traditionally, networking companies and internet service providers measure data traveling over a connection using that lowercase b, bits. But the hard drive on your computer and the files you actually save to it, well, those are measured using the uppercase b, bytes.
Section 4. Why it actually matters. Real-world use.
Let's walk right back through that frustrating scenario from the beginning of this explainer. Step 1, your internet provider advertises and sells you a package measured in megabits per second. Notice the lowercase b in Mbps. They are explicitly selling you a speed based on the absolute smallest unit of data. Then, step 2, you go to download a file. Your computer's operating system doesn't really care about bits, it stores things in bytes. So the progress bar on your screen displays the download speed in megabytes per second. Notice the uppercase b. Your internet pipe is pumping in megabits, but your computer is catching and measuring that data in megabytes. It's basically an illusion born entirely out of mismatched units of measurement.
And this brilliantly illustrates how the rule of 8 applies perfectly across the board as we scale things up for modern networks. Whether you're dealing with thousands of units, the kilo level, or millions of units, the mega level, it scales seamlessly. A kilobyte with a capital B is exactly 8 times larger than a kilobit with a lowercase b. A megabyte is 8 times larger than a megabit. It totally doesn't matter how many zeros you add to the end of the spec, the uppercase b will always represent a file size 8 times heavier than the lowercase b. Which finally brings us to the mathematical solution to our everyday mystery. If you're paying for an internet speed of 100 megabits per second, remember, lowercase b, you just have to divide that number by 8 to find out how fast your computer will actually save the file. 100 divided by 8 equals 12.5. Therefore, your maximum actual download speed is 12.5 megabytes per second. Uppercase B. Your internet provider wasn't actually lying to you. And no, your router isn't broken. You were just expecting an apple, and they were playfully selling you a slice of one that is precisely 1/8 the size.
It's honestly incredible how one simple press of the Shift key on a keyboard completely changes the reality of the technology we buy. Tech companies know that bigger numbers look way better on marketing brochures, which is exactly why they advertise in bits rather than bytes. But now you've got the tools to decode it. You know the structural foundation, you know the rule of 8, and you know how to do the math. So the next time you're shopping for a new data plan or reading some flashy tech spec, will you spot the difference between the lowercase b and the uppercase b? Stay curious, keep looking at the fine details, and thanks so much for joining me for this explainer.